Hello everyone, welcome to Mass Calculations, Standard Stoichiometry Problems. This is the 5th video in our Scale Factor Stoichiometry series. I'm excited for this one because this is the video where we are going to be taking a look at the real problems that chemists have to deal with. All the other videos leading up to now have been warm-ups. So let's go ahead and get this show on the road. And just a reminder that in order to be successful, you need to already know how to create a standard mass balance equation. You need to know how to use a situation value to create a scale factor, and you should know how to use a scale factor to rescale a mass balance equation. If those phrases don't mean anything to you, if you're confused, if you're lost, then you should go back to some previous videos in our series and watch them until you have a good idea of what's going on here. In this video, you will learn how to take the situation value for one chemical reaction and use it to determine the situation mass values for specific reactants or products. Let's take a look at what that means. But first, some cookies. So here's our cookie recipe, and it is in mass form this time. And let's go through some situations that might happen. Maybe you find in your house you have 100 grams of sugar. How many grams of flour should you use? Well, 200 grams of sugar is the standard, and I can kind of eyeball and see that I need that's half. Okay, so I need half the grams of flour. That's 225. 20 grams of sugar, okay, calls for 200. I've got 20, okay, so I need a tenth. That's going to be 45. What about 1.35 grams of sugar? Okay, so I can't do this one in my head, guys. We're going to go ahead and apply our scale factor approach. Scale factor is situation amount over standard. Remember, we prefer to sit over stand. 1.35 grams of sugar is the situation divided by the standard 200 grams of sugar. Grams of sugar cancel, so our scale factor is just a number. And then when we multiply our scale factor by the flour, standard amount, that's how much flour we're going to need. Now, I've only done the calculation for flour. If I was really going to do this, I would need to take the scale factor and apply it to all the other ingredients. But the question only asked me about flour, so that's all I'm going to do. I'm just going to do the flour because that's all I was asked about. And that's what we're going to see in our problems as well. So you will often have one chemical that determines your reaction scale, and you'll be told ahead of time that this is the chemical that's determining your reaction scale. It won't be said in those words, but you'll just be told about one chemical. Mass calculations typically ask you to determine one or more rescaled value. And it's just like rescaling equations, but it's a little bit shorter because we only have to apply the scale factor to the chemicals of interest, and often there's only one. Let's see what that looks like. So you wish to make 2 grams of silver by reacting copper with silver nitrate, and the question is how many grams of copper will be consumed. Here's our mole balanced equation, and then we're going to use that to create our standard mass balanced equation. There it is. If you're confused about where these numbers came from, please visit the earlier videos in our series. I will not take any time to explain them here, but you definitely need to understand how we go from this equation to this one. The situation quantity is 2 grams of silver. Standard quantity is 215.8 grams of silver. So there we're going to get our scale factor by situation over standard. Grams of silver cancel, very nice. And then what I'm going to do is, looking back at the problem, notice that it only asked me about grams of copper. So unlike in our last video, where I would have taken this 0.009268 and multiplied it through everything, it's going to multiply by the copper. That's all I was asked about. And there we are, we're done. So this is a standard mass question. I was given the mass of one chemical and asked to determine the mass of another. So if I want to make 2 grams of this stuff, silver, I need to put in 0.589 grams of copper. Let's look at another one. What mass of lead iodide will precipitate if 0.25 grams of lead nitrate is added to a solution with excess potassium iodide? And what mass of potassium iodide will react? There's your mole balanced equation. Let's get our mass balanced equation. Our situation quantity is 0.25 grams of lead nitrate. The standard amount is 331.2. Our scale factor will be creating the situation over standard, and the lead nitrate values will cancel with the units will cancel with each other to give us a scale factor of 0.0007548. And then I'm going to look at the question. It says, what mass of lead iodide will precipitate? Okay, so I will just apply this to the lead iodide, and we're there. Now wait, there's more, right? Because you saw there's that second one. So what am I going to do? What mass of Ki potassium iodide reacted? I will apply the scale factor, so potassium iodide mass, and there we are, scale factor multiplied by the standard amount, 0.251 grams of potassium iodide. It's possible that some of you would like to stay in comfortable territory. So if you really want to, you can just go ahead and do what we did in our last video. And you can just go ahead and multiply the scale factor by everything in the standard mass balanced equation. And then you'll just rescale the whole thing. And then you can go back to the question to look at what it asked you. It asked you what mass of lead iodide would be formed, and there it is. And then it asked you what mass of potassium iodide would have reacted, and there that is. And so if you really want to keep doing it this way, you can. But for those of you who know how to cut to the chase, you can save a little bit of time there. Okay, guys, it's time for you to practice. A chemist hydrolyzes 500 grams of water into its components. How many grams of hydrogen will be produced? I am giving you the mole balanced equation, and that is all. Here's another one for you. A driver's side airbag has 15 grams of sodium azide. If there's a crash and the airbag goes off, how many grams of sodium will be produced? Finally, there's the mole balanced equation for you. Your chemistry teacher wants to sell 2.5 grams of silver on the black market. Maybe he's got a little debt to pay off. Maybe he's had a little hard financial times with the coronavirus. At any rate, he's going to go ahead and react some silver nitrate, and he doesn't know how much to do. Well, he should be able to figure it out, or he doesn't deserve to be a chemistry teacher. So how many grams of silver nitrate does he need to react, and how many grams of zinc? And there is a gift for you. I have given you the mass balanced equation for this one. Save you a little bit of time there. So Merry Christmas, whatever day you happen to be watching this video on. Please pause the video. Do it. Pause the video. It's going to take you a couple minutes to solve these problems. So we're going to pause the video and work them out. And I will be here with the answers after you have worked them out. So please pause now. Okay, welcome back. I hope that you have paused for some amount of time and that you have worked out the answers. And I will now show you what I worked out. And there it all is for you. So we can see for our first problem, this is the standard equation. And then here we have our scale factor of situation over standard. Give us a scale factor of 13.9. Apply that to the standard value for hydrogen. 55.6 grams of hydrogen will be made in this reaction. Okay, here's our airbag. There's the mass balance equation. There's our scale factor using situation over standard, and then apply the scale factor to the standard amount of sodium. And that's the amount of sodium that will be made from this reaction. And then finally, our silver nitrate reacting with zinc for our black market chemist. And then you can see our scale factor is the situation over standard to get the scale factor. And then that is applied to the silver nitrate amount and the zinc amount. And I hope you got those numbers. If you are confused, I think watching the video again can be helpful. And I hope to see you soon in the next video where we will learn about limiting reactants.